domain means a group in a normal lame language. So so assume that group in our switching technology. Okay. So we'll come to that part. So, so it's a group. Now, you know what is a collision? What does a collision means? Collision means any,
intersection point.
yeah.
Collide.
So, sorry,
Collide.
some
Collide.
collide. Yes, some kind of like normally if I go onto the road and somebody is coming from here and somebody is coming from here with a high speed, what happens? They will collide with this one. Correct? So that is a problem. Now, what is the broadcast? You already know what is the broadcast. One to many. Correct?
One to all.
One to
Oh, sorry.
many.
Yes, yes.
Yes, sir.
All. That is multicast. One to all. So when I say one to all, I know that is a broadcast domain. So earlier in our days, what would have happened is like we used to have something called as hubs. So before switching, we will understand what are hubs. So hub works on some technology known as bus technology internally, not externally. Okay. So how it will be? So we'll okay, 1 minute. Control X. All of them are available now or still missing? 58. Okay, no issues. Okay. I may be slow quite today. Why? Because I'm facing some throat issue actually. So anyhow, I'll try. Okay. So here the bus technology was there in the hub. So how exactly the bus technology works? You know, there will be a terminator, and on the other side there will be also a terminator where you will be having some endpoints or the devices connected. The network devices are connected in here. But in the hub, it will be like you are having a device, and that device internally, so having some multiple ports, so it comes as 8 ports, 4 ports, or 16 ports like that. But after that, like they are, you can say they are obsolete now. Why they are obsoleted? Because it had lot many of issues with the broadcasting. So whenever the broadcast happens, now what happens? Your bandwidth will be utilized. Correct. So if the bandwidth is utilized, it means there will be a degradation of your network. Yes or no, guys?
Yes.
So,
Yes, sir.
so here, sorry. So degradation. Okay, okay. Degradation in your network and the slowness will be there with this one. So for that purpose, okay, we are coming on to that. So here we have ports, different ports, and these ports are actually connected with this in a bus way, and these PCs are connected with these ports now. Now these ports, do remember they are RJ45 ports, which actually connects with your Cat5 or Cat6 or whatever the cable. Okay, so we'll take that one as Cat5 and Cat6 only. So sorry. So we have the PCs. So in this scenario, what was happening? Like there is like whenever I'm sending any information from this PC to any PC in the network, what happens? That one will be sending out the information out of the port. Okay, we take that as read. So I'm sending some data on here. So what happens with this switch? Sorry, hub. It will actually rebroadcast it to this guy and this guy and this guy, this guy, this guy, this guy, and this guy. So there is no such thing like MAC address learning in this one. Okay. So there is nothing like MAC learning. So there was a problem. Like every time, whenever, like assume I'm actually in a class, I'm actually shouting, uh, who is Seshu? Now I'm getting the noise from all of the class, and all of the class guys are shouting, I'm not Seshu, I'm not Seshu, I'm not Seshu. And Seshu is saying, sir, I'm here. So what happens? His voice will be down, correct? So I may hear or I may not hear this particular voice. So everybody is shouting. I'm also shouting. I'm also saying who is Seshu every time. So whenever I'm shouting who is Seshu, I'm getting the voice from all of you guys. So it will not become a voice. It will be a noise for me. Yes or no, guys? So
Yes, sir.
okay, what is a voice and what is a noise? I'll just explain that one. Voice, which is actually uh, understood, understanding vocal. Okay. And noise is something which is not understood. So I'll just give you that information. Why? Why? Because see, if I'm speaking in English and you know English, it will become noise. Correct? Now, if I'm speaking in Tamil and you know only English, so it will become noise. Sorry, this is voice. Noise for you guys. Yes or no? So similar way, I'm not getting any information from anywhere. So I'm actually dropping or I may be hearing some information from there. So that was the problem from the hubs. So Cisco came up with a smart technology. Now in this one, you can understand there is the broadcast is happening. So this is termed as your one group is actually like to communicate, but there is a broadcast happening. So there is some problem in this one. So they came up with some name as broadcast domain so that only the people within that particular group can hear that. So we'll come to this part, how which particular technology it is. And then what is a collision domain? You understand that collision domain. Now I'm coming and he is coming. So at that time, what happens? This guy and this guy may collide with each other. So every time the colliding is happening or there is some problem with this one. So what happens? The packets or the information that I'm sharing. So if I take the information, so some information is actually lost or they collide with each other and they broke uh, over the wire itself. So that was a real problem in our network. So what they have come up with, they have come up with some new technology that is the switch. So switch has a good what do you call you can say that one. Every port, every port on a switch is a broadcast domain. Sorry, uh, a collision domain, and switch will be a single broadcast domain. Now, what this one will mean is like whenever I'm broadcasting any information, uh, sorry, broadcast domain is you can say it's a network segment where all devices can receive the broadcast information, or it can be said as it's a network area where the broadcast information or the data sent by one device will be received by the all devices within that area. So, what is my area? This is my switch and this is my area, correct? And if I have multiple switches, multiple PCs connected onto this one, so all you already have learned that initially the switches will broadcast the things. Now, after broadcasting, what it will do, guys, you can tell me. After broadcasting, what it will do? It will check from where exactly the information is coming back, it will take the MAC addresses of that one and create a MAC table, and it will understand, okay, these MAC addresses are on this particular ports, whichever the ports they are connected on. And from the next time, they will just pass the information to this guy. So what has happened now? Your speed will be good, correct? And there is one more thing that so will there be any collision?
Loss.
So no, why? Because whenever any port is trying to send the information, it says, okay, I will be on, I will be off until until I try to send the information over the line. If that particular line is not busy with some what is a electrical information. So why? Because internally it will be the electrical information, correct? So internally it is physical layer which is working behind that one. So one scenario in this one is like you have a road and you have a signal out here and a signal out here. So in this scenario, what happens? Until you don't see green light, red light, and the orange light. We'll take the same on this one. Red light, sorry. The orange light. So assume somebody is coming from this side. Somebody is coming from this side. Now what they will see, okay, they will say it is a green. So it will go off. It will, if it says, okay, we do not have this orange, leave that one. So red, it says, okay, I am out until that particular guy goes out from here on. Got it? Understood that? So earlier technologies didn't had, the hub technology didn't have this switching method. So what they were doing, they were just passing out the information from here to here and the collisions were happening. So switch got the technology that this technology can see, understand what exactly is coming over the wire and say that, okay, if any information is trying to come in, what I'll do, I'll just shut down, not shut down actually, I will pause my information to be sent onto the wire. So that is what was happening on that one. So who is responsible for that one, guys? Which particular sublayer is responsible for that? I said sublayer.
Mac.
Mac, are you sure?
Yes.
Okay, good one. So Mac is a technology which actually communicates with your lower layers and the LNC upper layers. Got it? So this guy will understand what exactly is happening over the wire and then it will just off. So we turn something called a switch as on off. So this is the same technology, but do remember this is in micro milliseconds that it is happening. You can't understand how it is happening at the because it will not have any delays or something, correct? No delays. It will just wait for some time and it will just will pass out the information over the wire on the other side. So the collision domains have been, you can say like it is totally like, can say that one as over the shared line. This is the shared line because everyone is using this particular section only so that they can set. So this is being shared with multiple users. So internally it is a bus, but again, switch is a quite smart one. It has a MAC addresses, correct? Minutes, guys, I'll just pause
Yes.
something. Okay. So MAC address information, then it will solve that issue where exactly it has to send out the information from. So if I take a scenario like I have, so for an example, even our router, ports are one broad ports are one broadcast domain. Got it? So there is no collision domain in our routers. So there will be no collision domains because it just have to send out the information. So if I take a scenario of my router, so assume this is my router. So I'll be having maximum up to 2 ports or 4 ports maximum. So 2 ports, every single port is its own broadcast domain, but it doesn't have any collision. Why? Because routers doesn't work on your MAC addresses. Okay. Although they will have the MAC addresses only for your LAN segment, but when they are communicating with other things, they will never say I'm coming with layer 2. They are layer 3. Yes or no, guys? So what protocol works on your layer 3?
IP.
IP. Good. So there is no collision domain on our routers. So I'll come up with one small example so that you can understand it better. So I have switch. So I'll take that one as a switch. And I have one PC out here, another PC in here. This one is one PC in here, and another PC in here. And now I'll connect some router in here from this router. So how many? Okay, I'll just give you like how many collision domains are there in this one?
One.
Okay, one.
Yes.
No, I'll give you scenario. So I said, so if you remember, every port. So 1 minute. So okay, we will understand that one as the first. We will understand that one as the broadcast domain. So what is the broadcast domain? It is only
Where all receives the same.
yeah. This segment is only the information that this switch can send out the information, correct? So these are the ports. So every port it will only send out the information from there. Can it send it to this guy? It can't, correct?
Yes.
Okay. If it wants to go out, now you know it has to come through the router. A router never works with MAC addresses. It will work with your IP. Yes or no?
Yes, sir.
Okay. So now this one is another broadcast. What do you call that one? Domain. So within this group, this is one broadcast, and this one is one broadcast. And how many collision domains are there in this? So collision means what?
Two.
It will do. Okay.
Two collision.
See, every port of a switch, every port connected is a collision domain. On a switch. Got it?
Okay.
So this one, so how many cables are connected in here?
4. Total.
4. Okay, and take that one as green. Okay. So this is one collision domain. The second, the third. So I'm just going on to the switches actually. 3. And then you got this has 4 and 5 and 6 because every port sees out the information what is going on over the wire, then it will send out the information over that wire. So every port is your collision domain on a switch. Understood, guys? So this
Okay.
is one broadcast domain, sorry, if I make that one as green, you will understand it differently. So this is one broadcast domain, and this is the second broadcast domain. Second, not two. Okay. First and second. And every port that is connected over the wires on the switch is our collision domain. So if I add, there is one more information out here. So in here, I have, okay, I just draw that one, but I forgot actually. Okay, good. See, I forgot the diagram which I just draw. Okay, I have a router and I have a switch on this side and the other switch on this side. And this port is connected with something called as a hub. So this is my switch. This is my switch. So I have another hub out here. And now I have some PCs in here. This are my PCs. Now tell me how many broadcast domain and how many collision domains are there. So this is again the hub.
8 collision domains, 2 broadcast domains,
8 collision domains.
2 broadcast domains.
Okay, so this one is my, okay, I'll go with blue. This, is a single broadcast domain, correct? So no,
Yes, sir.
Yes, sir.
Yes, sir.
okay.
Sir, only 4 collision domains.
And this one is also a broadcast domain, guys. Why? Because there is a hub working in this one. Got it? Because it will have your, what do you call that one? The broadcast happening in this one every time, correct? Okay. And this one is one, another. And then again, here, this guy. So I'll take this guy direct. Another broadcast domain. So there is a problem. And this is my collision domain. Okay, I'll make that one as green. This is my collision domain. And this is my, oh, sorry, this one I have taken as broadcast, but it has to be like this. And this is another broadcast. Sorry, collision. And this is another collision. So how many now? 1, 2, 3, and 4 broadcast, correct? And this one is 1, 2, 3, and 4 broadcast. If I connect this PC, collision as action. If I connect the PC in here, then again this particular port will become my single collision domain again.
Collision.
Yes. So that's why you're understanding. No need to worry about this one. Sorry.
Please repeat once. Little bit
Okay.
confusion.
Okay. Any hub is a broadcast domain. Okay. And anything that is connected over the switch, okay, is one particular broadcast domain. Understood? Understanding that. So if I have a switch and it is connected with the hub, and this hub will create one broadcast domain. Got it? And the switch, which is the wire that is connected over this hub, is one collision domain. Got it? So here, this is what happened just now. You'll see that again if you want. I'll delete this one, guys. Okay. Clear manner. I have a router. Big black. I have a router. And I have some switches. I have some hubs. So till here, this or no? This one and this one is one. What? This one is what it is. coming from the switch? One collision domain, correct? One collision domain. And this is another collision domain. And this is connected with this particular hub again. So this is another collision domain. This is another collision domain. Got it? So now if I connect my PCs onto this one or no, PCs in here, this one, we'll take this one only. This one will become my what? What it will become, guys?
Broad domain.
Broadcast.
So this one and this one are
Broadcast.
Broadcast.
your broadcast domain. Why? Because you know the technology of the hub, it only broadcasts. It doesn't have any smartness. It will just forward the information whenever anything is coming over here. Got it? Who asked us to repeat? Is it okay, Miss? Got that? Or you have still you
Yeah.
still have the confusion? Please let me know.
No, no, sir.
Okay, good. So this is what happens in our networks. So when we talk about the switching, so just for your information, these things are really important, but it's better you mug up the things for the collision domain and the broadcast domain. Why? Because in real scenario, this information is will not work nowadays. Earlier it was really important, but now it is not important for us. Why? Because the hubs are out of our networks now. So why they have been removed? Because of the issues of your what do you call the packet drops, the frames are getting collided, and the collisions were happening, and the broadcast was happening every day, every time actually. So that's the reason they have been moved. Even a single switch, which is even a switch that is something like 200 or to 500 range rupees. Now these are coming as a switches now. They are quite smart now. Okay, so they have. So if it is coming for the cheap, who will buy the hub to have the effect of get the impact of collisions, all those things in the network? Nobody. They will take the normal switch, which actually works out with your single broadcast domain and multiple collision domains depending upon how many ports that has. Got it? So every single port on a switch is a collision domain, and this switch is actually one broadcast domain. Got that? Clear with that? Guys?
Yes, sir. Yes,
Okay.
sir.
So okay, so coming on to our something called as you know what is a binary, correct? What is binary?
Bit representation.
The bits, okay? And then we have the decimal. What is the decimal of what is the decimal?
Numerical.
A numerical value of your binaries. Now coming on to our, that is your hexadecimal now. Okay,
0, 9, A to F.
good. So whenever we have some extra value for this one. We will understand that. So in the binary, any digit that is you can say has a value of 0, what it is termed on decimal side?
0,
0. So in the
Zero.
hexadecimal, what it will be?
0,
It
Zero.
will be 0. Okay.
Yeah.
Then we have the value of bit 1.
1,
1 minute. We will go with some other way because there is another thing that has to come actually. So I'll go with this 1, 2, 3, 4. Okay, this will be easy. So 0, 0, 0, 0. The binary is 0 every time, and hexadecimal also will be in a 0 value. So when I say 0, 0, 0, 1, what it will be the value on decimal side?
1.
1. And the hexadecimal also has a
1.
1. Now, when I say 0, 0, 2, sorry, not 2,
1 0.
1, 0, yes, what it will be?
2.
2.
2, you know that, you already have that
Two.
info. And then we have 0, 0, 1, 1, that is
1,
your
1.
bits on
3.
3. So we got 3.
Three.
Now 0, 0, what is the next one? This one, okay,
1,
here,
sir. There is 1.
0,
Zero.
1, and 0, 0.
0.
So that will be a
4.
4.
4. 4.
So now 0, 1,
1.
0,
0.
1
1.
5.
is 5.
5.
Yeah, 0, 1,
1.
1.
1, 1,
0.
0.
Huh? 0, sir. There is 0.
0. Okay, 4 to 6. Yes, good.
6.
Thanks, guys.
6.
So it means like you are actually like you'll actually like this training act. Good to hear that.
Thank you, sir.
Okay, good. So we'll go with what is next
0,
for
1,
7?
1,
0, 1, 1.
0 1 1 1
1, 1 is my
7.
7.
7.
Girls,
7.
are you getting this one or not?
Yes, sir.
Okay. Now you have to shout actually. Why? Because nowadays, if you don't shout, it means you are not capable enough. So you have to shout. Okay. So what is the next?
1 triple
1,
0.
0, 0,
0.
0.
0.
Yeah. So what it will be?
8.
8. And then we got 1, 0, 0,
0,
1,
1.
9.
9
9. And then 1, 0,
0.
0, 1, 0, 0, 1, 0. So that will be your 10.
10.
Now what comes in your
9,
hexadecimal now?
A
A. Okay. Now we can't have 10. Why? Because if it is 10, you know what happens. Correct? So the 10 refers to your 0 and 1. So it will be like this. So the 1 comes here first, and the second one will be this one. So it can't understand what exactly that one is. So what do you say? The IETF, there is a team as I'm not remembering this guy, International Engineering Task Force. Yes. International Engineering Task Force. These guys have defined these values actually. Okay, there's a lot of research for this one. So I'll just move ahead with one another addition, the line. Okay, now comes your 1, 1.
0,
Is it? Yeah, 1, 0, 1, 1.
1
So
1
it will be
11
8, 9, 10, 11.
B
It will be B. So similarly, now if this one is needed, so for that purpose, we will write all of them. So 1, 1,
1.
0, 0.
1
Yeah, what it is? 8 plus 4 is 12.
12
Yeah. So it will be at
Say
C
C. So 1, 1,
1.
0,
0
1
1
is 13. So
B.
you got B. And there is next is 1, 0.
1.
Oh,
1
sorry. 111, correct? This is
yes
0.
sir
So 4, 8 plus 4 and
2. 1.
2. How much it is? 8, 9, 10, 14. Correct?
14. Yes, sir.
yes
Yeah. E.
E.
And then we got 1, 1, 1,
1 1
1.
1.
That is your
15
15.
15.
So how many
Yes.
characters we got?
15. Correct.
Not 15.
16, sir.
16.
16
Including
16.
0.
Total is
0
Yes.
0 also.
So 0 to 15 is my
Hexadecimal.
hexadecimal numbers. Now hexa. Now that hexadecimal numbers or characters have been defined as A, B, C, D, E, F with a for so that we can understand the bits can understand what exactly the value is coming from the other side. Okay. So in this scenario, like Why exactly we have learned this hexadecimal information? Because our MAC address,
Will be in
MAC,
hexadecimal.
yes, MAC address is in hexadecimal values. Now this hexadecimal, now why I'm giving hexadecimal value. Now when I say hexadecimal, okay, now do remember after F you don't have anything. So if anything is coming as like this, it doesn't represent your character, that is your alphabet. What it represents? It's a numeric. What does the numeric mean? Zero, correct? So do remember about this one. And even I, we don't have. This is normally the capital I that we write uh, in real scenarios. So this one is an alphabet, correct? So in our scenario, if it is what do you call that one, hexadecimal, it is actually a numeric again. Now, what is this? This mean this is your one. Yes or no?
Yes, sir.
So don't ever think like you have a zero or one on my MAC addresses because it only from zero to F. That's it. So what is my MAC address? Okay. Yeah, I'll go with this one. So I can see it from my Ethernet. Change adapter settings. I'll go with this guy. The properties and I think this is the one. Let's see. I'm not good with this. What do you call that? Yeah. Where you see this? What do you call that? MAC address, guys. We got this. Hardware ID. It is in this one. Where you see the MAC address?
So you can type ipconfig slash all in the command prompt.
But I want it here actually. I know that ipconfig slash all or ipconfig it will give us. I want something different actually. Let me try, guys, because in real scenarios, you may be. Let me. Yes. See this. You got the physical address. Now we talked about the MAC address. So what it is? 8C. Let me type it down. I'll write it down so that we can have one minute. Good. Okay, we have 8C-6-83-AD-74. Good. I needed that. Now, you may be seeing this as sometimes you may be seeing this one at 8C6 and then colon 8183, then colon and then AD74 like this also. Okay. And sometimes you may be seeing that one as 8CC colon or dot. Okay. Dot 681 dot like this also you can see. But do remember they are all physical addresses. So what is a physical address? What does the physical address mean? Guys, you know this. Go ahead, try.
MAC address.
Yeah, physical address means it is actually engraved on the network interface cards. Hope you remember now this one.
Yes.
Okay. Now, if you don't remember that, at least remember this in Telugu, Bindi. What does the Bindi mean? Your pod, correct?
Yes,
So
sir.
if you remember that,
Yes.
before, yes, good. Good to hear that. Okay, so we got the MAC addresses in here. Now, every bit, every number or a character actually defines character. How many bits, guys? These are how many bits?
4.
4 bits. We got 4 bits. So every character in the Mac, every character in the Mac address is of 4 bits. Important thing. Now, like you remember IP address, every single bit is a single bit, but one octet is of 8 bits, correct? So we say this one octet. Now we also say this one as an octet, but why? We will see that one later. Okay. So you got this. So what is the value? So if I say 8, you already know what is the value of that one, correct? So that is your 1000. That is your 4 bits. 1 bit on, 3 bits off. Yes or no, guys? So here C means, what is the C? Got just 1100. So how many bits we have used in here? So every single bit. So this one is 1111, and then we have 1111. So this one combines is termed as octet, but every what do you say? The 4 what do you call it? Binaries or values is your value of one character in our MAC address. Now, how many numbers we have? This one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So MAC address is of 12 characters. Yes or no, guys?
Sir.
Now 12 for the
48.
48. So MAC address is of 48 bits size. Understanding, guys? So 48 bits, you know what is 48 bits? Every single character. So this one is 1 bit. Sorry, this one is 4 bit. 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 Similar way, all of them are there. Now, what is the highest value? You know that lowest value in the hexadecimal, that is your 0. And what is the highest value that we have?
F.
1F.
Okay, we already have it. Why to draw them? So highest value is F.
111. Yes.
1111. All bits on and all bits are off in our MAC address, whatever the value that comes as. Question, guys, anything that you are missing or you didn't understand that, please let me. Yeah. Can go. Try, man. Okay. So shall I go ahead next?
Yes.
Yes, sir.
So I'll just go
Yes,
ahead.
sir.
Good. So now, oh no, man, I needed this. I'll take this, Control X, Control A, delete, B. Good. So now, you know that one. Like, how many octets we have in this one, guys? You tell me.
3.
Yeah, anyone? We just talk.
6, sir.
6.
6.
Okay, this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. Okay, even if they write something like 8cc dot 681 dot 838 dot AD74, they remains the same. Okay, even if it is 4 or even if it is 8C colon C6 colon. So every time do remember it is octet means your 8 bits, correct? So every single bit, so every single character is of 4 bits. Now you will be like you will have confusions, okay? But don't. In the real scenarios, the questions will be like this only. Clear, guys? Question. So I'll just delete this one because note down this one, guys. It's very important. Okay. So coming on to our MAC address information, you will have something called as your OUI, organizational unique identifier. Okay. So first 24 bits. First 24 bits of the MAC address represents your organization unique identifier. Now, what does this organization unique identifier mean? Now, say this: I own a company. Like, take a scenario like, okay, so we'll take Hunt Matrix and assume this Hunt Matrix is actually it produces the NICs, that is your network interface cards. So, shall I write the abbreviation for this one? Okay, let's go with that. So, network interface cards. Yes. So I purchase. So I have to go to. So I have to go to something like the IETF. Okay, not IETF. IANA. Okay, I forgot to tell you. I think that IP addresses have been given by you something called as your IANA. What is IANA? Please search that because these abbreviations I don't remember. Okay, we'll talk about that. So we have the IANA, and they will provide you what do you call that one as the IP addresses. Okay, that is your public IP. Do remember that public IPs and the MAC addresses even. So whenever Hunt Matrix goes to want some, they want to produce network interface cards. So they will go to the ANA and say that we want some what do you call that? We want some MAC addresses so that we can use it for the production of the network interface cards. Now, this interface cards, how many it will be? Like I said, 24 bits. Now, what is the 24 bits numbers will be? How many? What will be the decimal for this one? Anyone can try. No problem. Try out. You have a PC. You have the internet. You have your chat GPT. You can try with that. Tell me, guys. Try. Anyone? Or my voice is not reachable to you? Guys, I can't hear anyone.
Sorry, reachable.
Yeah, thanks. So we got it. So the number that we got is 167772216. Rohit, thanks a lot. So these many IP addresses. Now, how much it is? If you count in millions, what it will be? One minute.
16 million.
So 16 million. So 16 million something. So 16 million means what? How much is a 1 million? That is your 10 lakhs, correct? So 1 crore 60 lakhs or 77 something like that. Okay. So those many of NICs I can make from my whatever the MAC addresses they have given because I'm using my address initially for my organization. So this from here to here, correct? So we got this one as 4, this one has 4 bits, this one has 4 bits, This one has 4 bits, and this one has 4 bits. So this one has 4 bits. So 6 4 are 24. We got 24. So 24 bits I have actually got it from my from the INR, so that I can have only this number initially. So what numbers I can utilize? I'll show you that one now. So 866, 8666. What is the next one?
8183.
8183. And really, really good. 8183,
AD74.
AD74. So you are good with the phone numbers even, I think. Correct? Do you remember the phone numbers even? AD74.
4.
Yeah, thanks. And you're really good. Okay, 87.4. I can't remember even this one actually. Okay. Now, so I'm utilizing till here. After that, I can utilize this one for my what is it? Next what is a MAC numbers. So I have taken that one as 24 bits right now. Why? Because you know this one is also 24 bits. So totally 48 bits minus the 24, we got 24 bits. Yes or no? So here we have organizational unit. After that organizational unit, what I can do is I can start like 87cc6.81. Okay, we take that one into 8c colon c6 colon 81. So we will leave this one till here. From now, I can start from 00 the AD 74 and sorry, not AD 74. See, I missed up. So it's the time is coming up. That's the reason. So 00 colon 00. So from here I can start and I can go till what? You know, guys. Yeah, till what? I can go
255.
F F F F F F. Yes or no, guys?
Yes, sir. Yes.
Okay. So we know that every bit is individual. Every character is an individual 4-bit
4
size.
bits.
Okay. So do remember this one. So I can go to here and that one become like the number that has been given like 1677 something XX. I don't remember that. So it can go up to this one. So the after like ended up with this all, what I have to do, I have to go to Anna again and say that my nicks have been produced. Now I want another number. Now they will give you another OUI, organizational unit. What is a what do you call it? Identifier. Yes.
Identification.
And this one will be your nick specific. Why it is specific? Because we have made that. And do remember, that's the reason the MAC addresses anywhere in the world are unique, similar to your IP address. Okay, but there is one more thing. IPs can be same in the private networks, yes or no? Guys,
Yes.
Yes, sir.
okay. So, but the MAC addresses are unique everywhere. But there is also a scenario like I can utilize the max or not to go outside only for my inside network. I can do that even. But who will actually purchase the MAC addresses for your inside network? Nobody, correct? Why? Because every PC wants to connect to the internet, yes or no? So
Yes, sir.
if they are connecting over the internet, now you will have the layer 2 header added information with the MAC, correct? So it will carry on the information to the internet, and then it will say again, if it is having the same duplicate MAC address in the anywhere in the world, it will be a problem, correct? So similar to our private IPs, we also have kind of private Macs also, but again, we don't use that. But in some scenarios, maybe I never have seen that, but you can say that like maybe some research or development for something, they may be using this one. Got it, guys? Any question?
No, sir.
Today, you guys are very dull. Why? Because of my voice or something?
No, sir, nothing.
And you have to be very proactively work on this one, guys. Okay.
Sir,
So-
NIC means network interface cards or controllers, sir.
Card. You also say that one as Nick network is not controller, it is card.
Okay, sir.
Okay, network interface card. What is the interface card? You know that. I don't want to go with the. Okay, so let's go with this. What is that? You're asking. Okay. Nick, let me correct. Okay, I'm correct, thanks. Okay, thanks. So network interface card. Now this network interface card, you know how it will look like. This kind of. Or if it is in your PC, you will only see this one. In the port that is it is showing us. Got it, guys? Yes
Yes,
or no?
sir.
Yes, sir.
Okay, good.
Yes, sir.
Yeah. So okay, I passed my time and I'll rush, guys. Thank you for your time. But tomorrow it's Friday, guys. Okay, so we'll have good time on our learning path. So
Yes, sir.
so thank you, guys, and take care and try to understand the things in a way that you can remember those things. Okay.
Yeah.
Thank you.
And
Thank you, sir.
Thank you.
anyone tried for this what do you call the IP addressing? What do you call that subnetting part? Anyone tried?
Yes, sir.
Okay, good. Have you tried on the website that I have given? Because
Yes,
it will give you the full information what it is.
Yeah.
Yes, sir.
Okay,
Yes,
good
sir.
guys. So practice that thing.